SwayamPrabha. Digital India. Educated India.
Hello everyone, today I am going to deliver a lecture on residual stress, especially the residual stress which is developed due to welding process. It is a very important topic nowadays, and what happens, there is lot of scope in the field of welding related to residual stress topic. So, this is the content of today's lecture. That means, first of all I will discuss about the introductory part of residual stress, then I will discuss about how this residual stress formation is taken place, then what are the different categories of residual stresses, then what are the effects of residual stress, then residual stresses in weld, then factor influencing the residual stresses and how we can control this residual stress. Then I will show you the methodology for prediction of residual stresses. Now, before going to discuss about residual stress, first of all we should know what is stress. Now, here we should keep it in mind, when the deformation force is applied to an object, then we know the object deform, correct. So, in order to bring the object back to the original shape and size, there will be an opposing force generated inside the object. Okay. This is a restoring types of force on the stress level is within elastic limit, that you can say. That means, this restoring force will be equal in magnitude and opposite in direction to the applied deforming force. This you should keep it in mind. So, the measure of this restoring force generated per unit cross sectional area of the material is called stress. So, how we can define this thing little bit more general way I am going to show you here. So, what is stress? Stress means, this is a body. So, once we apply a force P here, then due to this force P, what happens, if we take due to this force P, this body will deform, this body will deform. So, once there will be a deformation, then all we know there will come a strain. So, we know from the Hooke's law till elastic limit, or you can say till proportional limit, we know that is in Hooke's law stress is proportional to strain, that is called engineering stress is proportional to engineering strain. Now, once we just make it equal, then we can get a constant E, that is called Young modulus, E into epsilon, this is called Young modulus of that material. So, this is an important property of a particular types of material. Actually, this Young modulus is actually the slope of what it is called stress by strain, that we can say, because if we draw the stress strain diagram, so till proportional limit whatever the slope we get, that means that slope of what it is called stress by strain is called this E or Young modulus. This is a very important property of material. So, from where we can easily get this stress. So, this stress, what is the sense of this stress, how we can feel this stress, because once we apply a force P, then what happens, if we take any cross section, let us XX cross section I am taking, if we take any cross section here, in this cross section what happens, there will develop a resisting types of force. If we just cut this section, then there will be develop in any section if we will take, there will develop a restoring force which is equal to the externally applied load, because generally the body should be always in equilibrium, what I am telling, understand. Then only what happens, your structure will be stable. Okay. Now, what happens, this restoring force is developed. Now, always keep this thing in mind, this restoring force, let this restoring force is P dot. So, always keep this thing in mind, this P dot restoring force should be equal to the P. Now, what is the definition of stress? The definition of stress is called, let us P sigma equal to this restoring force, that means P dashed divided by this cross sectional area. Let this cross sectional area of this bar, or you can say let this body is a square in cross section, let this is the cross sectional area. Now what happens if we just divide this thing, then what happens, we can get the stress, correct. So we got the idea, the what is the stress. Now what is the different categories of stress? You know that generally there the stress we can divide into mainly two different categories. One is called a tangential stress, or is called shearing stress. Another one is called normal stress, that is generally acting perpendicular to the plane of perpendicular to the plane or cross section direction. Okay, that is called normal stress. If some stress is applied along the or parallel to the plane, then what happens, that is called generally shear stress. Or we can define like shear stress means when the direction of the deformation force or external force is parallel to the cross sectional area. So along the cross section, whatever the stress is developed due to this parallel force, that is called shearing stress. Okay. This result generally due to the shearing stress, generally it result in deforming the body. What I am telling, understand? So I am not going in details about this stress and stress. So you got the idea. When we applied a force in a body, then internally of that body there is developed a resistance force, or you can say restoring types of force, which try to return back that body to its original shape and size, correct. Because once we remove this external load due to this restoring force, or you can say resisting force inside the body, it try to return back that body to its original shape and size if it is in elastic range. What I am telling, understand? So that force per unit cross sectional area, which cross sectional area we should consider? The plane at which we are interested to find out the stress, that plane cross sectional area is called the stress on that plane. Okay. Now what is residual stress? Now we got the idea stress. Now we will discuss about what is residual stress. Residual stress means, you see, a residual stress is that stress which would exist in a body if all external loads were removed. It's also, so that means what is the cause of this stress? Generally the cause of the stress is, we got the idea, that means this external load P. Now what is residual stress? If the situation of this body is such that if we develop this P, or that means external load from this body, and if then also there will be some stresses inside the body, that stress is called residual stress or locked in stress. So what we can say in another way also, we can define this residual stress, that means stresses that remain in a solid material after the original cause of stresses has been removed. That means if this external load once we will remove from the body, then internally whatever the, if there is remains some locked in stress, that is called residual stress. In a body, this residual stress is self equilibrium types of stress, that we can say. That means we know this equation of equilibrium, that means to be equilibrium of a body or a structure, it should satisfy some equation in the sense, for two dimensional case, that is summation of fx should be equal to 0, summation of fy should be equal to 0, and what it is called, moment about any point of that structure of all forces should be equal to 0. Now what I have told you, this residual stress, due to this residual stress, whatever the moment force generated in the body, if we just sum it up along x direction, along y direction, along z direction, and if we take moment about any point of that body, of that all the force component due to this internal stresses, or you can say this residual stresses, then we will get that summation of all moment about any point of any cross section, if we take, it will be equal to 0. This you should keep it in mind. So residual stress, whatever the stress develop inside the body, and what is the stress remain after removing the loads, stress or self equilibrium types of condition, generally they are developed. Okay. This residual stress also sometimes called internal stress, it is also called initial stress or it is also called locked in stress. What I have already told you, because it is the internally developed restoring or resistance force, that is why this stress is called internal stress. This is also called initial stress, because what happens, this stress remains before application of other loading condition. That is why what happens, as it is generated due to the manufacturing process itself, that is why what happens, you can say this is act as a initial state, because after that further loading and other external load is applied. That is why it is also sometimes called initial stress, or this is also called locked in stress, because this stress is locked inside. How it is, that also I will show you. Now, residual stress, here one thing you should keep it in mind, residual stress once it combined with this service stresses, that means if let us say body is subjected to some residual stress, after that if we apply some further load over this, then this residual stress act as a initial stress, correct. So, further load once we apply, then what happens, it's generally, that is why here it is written, this residual stress combined with service stresses, that means further loads on once we apply, that is called service, that also creates some stress, correct, that is called service stress. That service stress generally combined with residual stress is responsible for unexpected failure of the component and reduce its functionality. Definitely, once there will be some initial stress inside the structure, definitely its functionality will reduce, correct. And here one thing you keep it in mind, always this residual stress is not bad types of effect. Some type of residual stress are there which is generally have some good effect also. Like for improving the fatigue resistance, generally compressive residual stress can be introduced into the component by some mechanical means. Mechanical means like one of the mechanical means by like some short pinning technique. By the short pinning techniques, generally we can develop some compressive stress on a body. That is why this compressive stress generally improve the fatigue life of a structure. This you should keep it in mind. Okay. Now, how this residual stress formed? So, residual stress generally have different types of sources. Like always keep this thing in mind, it is generally formed once there is a sharp thermal gradient, then there is a chance of formation of this residual stress. How it is, that I will show now. Okay. It is also can be developed intentionally, because what happens, what I have told you, residual stress generally improve the fatigue resistance, or in some cases it is also increasing the static loading characteristics. That is why it can also be intentionally introduced to the component either by some mechanical means or by some thermal means. How it is, because you know that what I have already told you, mechanical means by some short pinning or short blasting, and thermal means by some heat treatment process. Heat treatment process like for toughening of glass, you say whatever the tempered glass we use, that tempered glass generally in this tempered glass intentionally we introduce some compressive residual stress on that tempered glass. That is done by some heat treatment process. Especially this heat treatment process means it is a rapid heating and rapid cooling process. Generally this glass is tempered around 600 degree centigrade temperature. After that, once it is rapidly cooled by some force cooling technique, then what happens, this compressive types of stress or temperament of the glass is taken place. This act as a resisting from breaking of that glass. Okay. That is why you see that is this residual stress intentionally also we provided in the structure. It also can be produced by unevenly distributed non-elastic strain, that means unevenly distributed plastic strain, we can say. Non-elastic strain means you can say plastic strain. Once there is a non-evenly distributed what it is called plastic strain, then there can be residual stress. How it is, that I will show. And it also can form due to misfit between different regions of a structure. So, this is also can arise due to misfit of different region. Okay, because especially misfit means let us some non-uniform deformation of a bend bar. Now, I am just going to show you how this residual stress actually arise. This you should know. Now, what is residual stress? I have already told you. So, you got the idea, it is a locked in stress or internal stress, correct. Now, what I have told you, if we apply a force P, then what happens? You see, then due to this application of force P, it has a deformation. Let this deformation initial length was L. Now, let the increment of length is delta L, correct, delta L. Now if we remove this force P, then what happens? This body will return back to its original shape. Okay, that means this stress will release and it's return back to its original shape. Now, let's this first body, let this body 1. Let's initially it was like this. Now, it has 3 different layer. It has 3 different layer. It has 3 different layer. Now, I am just for your understanding, I am just showing this thing. This layer, and this layer, this layer and this layer is fixed condition. It is not subjected to any load. Now, it is subjected to some force P. Now, what happens if we take any section in this middle layer? If we take any section, you will get there is a internal restoring force P, correct, internal restoring force P. So, or other way we can discuss this thing, then it will be more clear to you. Let us say bar is subjected to some deformation. Initially it was like this, So, after that it has some deformation P, After that, if we apply some component or some other layer over this, this is one layer I have provided, this is another layer I provided here. So, you see, initially this bar was have a length L. So, after that this bar have a length L plus delta L, correct. Now, you see, due to this top layer and bottom layer, which is generally, now if we remove this top layer and bottom layer, left after elongation we apply this top layer and bottom layer. After the elongation we apply this top layer and bottom layer to be in that elongated position of this bar 1, now which has a length delta L. Now, if we remove this load P, due to this top layer and this bottom layer, this middle layer, that is layer 1, will not be returned back to its original length L. So, what happens? Due to this top layer and bottom layer, it is resisting this returning back of that layer 1 from its elongated position, correct. So, due to this, what happens? If we remove this force P there, then also what happens? This bar, or you can say this layer 1 will be elongated condition. Why this is elongated condition? Because due to the support of this top layer and bottom layer, correct. Now you see, so what happens? That is why what happens in this layer 1, due to its non returning back from its elastic state to its original state after removing of this load, what happens? There is developing some internal resistance of that structure, or internally there is developing some resisting force, correct. That resisting force generally locked in due to the support of other layer, you see, due to the support of other layer. Now if we just release or remove this top layer and bottom layer, then what happens? This middle layer will return back to its original position, then your stress will not be there, like that locked in stress will release. But what happens? As it is locked in or supported by some other supporting condition, that means other layer or other supporting condition, due to this thing what happens? Inside that component there is developed, or like here it is layer 1, there is developed some internal resistance, because it is always try to returning back from its elastic strain condition to its initial state condition, correct. So, what happens due to these things, or there is developed some internal resistance. That internal resistance, if we just remove this bar 1 from this two top layer and bottom layer support, then what happens, this bar 1 will again return back to its original position. Then at that time this stress will release, because we know till elastic limit, if we just draw the stress strain diagram, what we have seen, this stress is gradually increasing, after that it go to plastic state, and finally it is like this, like just this is the mild steel types of stress diagram I am showing. So, you see till elastic limit, let this is your real point. So, till this is here generally elastic limit is there. So, from here if we just remove the load, it return back to its original position, and what happens, the stress, whatever the stress is there, this let us say in this elongated condition, there is a stress, let us sigma 1, okay, or sigma elastic strain stress. So, once we release this load, or once this release from the load from this sigma e stress level itself, it's return back to its original position. At that position this stress will release, and what happens, inside the body there will not be any stress. What I am telling, understand? Now, we see this top layer and bottom layer, once we remove from this middle layer, then you see this middle layer again return back to its original length L, correct. So, what happens, at that time there will not be again no stress inside that body. This you should keep it in mind. Okay. Now, you got the idea what is locked in stress, how is locked, this idea you got, correct. So, what happens, once there is a non-uniform types of deformation or expansion types of phenomena in a structure, there is a chance of this locked in types of stress inside a body. So, due to this what happens, non-uniform expansion or contraction phenomena in a body, one layer can act as a support of another layer from preventing the expansion and contraction, correct. Due to this thing, what happens, inside the body there is developed some restoring force in different layer of the body due to non-uniform expansion and contraction. Due to this thing, what happens, in some layer there can remain some what it is called a stress, or you can say initial, or you can say locked in stress. Now, if we just cut that section, or if you can say if we just remove the support from that section, this will return back to its original position, correct. That means then stress will be released. So, as that types of cutting and other things is not there, that is as this is locked with some supporting condition or supporting layer, that is why what happens, that stress remain as a initial stress in the body, which is called residual stress. More details I will discuss in subsequent slide, then it will be more clear to you. Now, you see categories of residual stress. Residual stress can be categorized into 3 different categories. One is called type 1 residual stress, which is called macro stresses. This macro stresses, why it is called macro stresses? Because these types of stress vary continuously over a large distance, macro level, okay. That means over a large distance it is continuously vary. These are the stress which are generally large in scale and may be developed by inhomogeneous plastic deformation, which I have told you. That means wherever there will be some inhomogeneous types of thing, that means non-uniform expansion, non-uniform contraction through the thickness, through the surface, whatever it is, then what happens, there can be developed some locked in types of stress due to support of one layer with another layer. That means there can develop some locked in types of stress. So, you see this macro stress is developed generally in homogeneous plastic deformation. This plastic deformation can arise from external loading, this can arise from non-uniform heating or by some varying chemical diffusion or alloying, particularly in surface zone. So, you see this is called type 1 or you can say macro residual stresses, macro level residual stress. Now, you see what is non-uniform or inhomogeneous plastic deformation, little bit idea I am just giving you. Let us you see let us here we do the welding. Now, heating is done from some arc, correct. So, what happens, as the arc is heated from top of this plate, you see top of this plate, that is why what happens, definitely this near to this arc the temperature will be more, and what happens, it is gradually decreased through the thickness of the plate, correct, through the thickness of the plate. As well as you see, due to the heating of this welding zone, if we just go in width direction of this plate, you will get there is a continuous decrease of temperature. There is a continuous, because the temperature will be more at weld zone, and what happen, it is gradually decrease along the width direction, as well as it is gradually decrease along the thickness direction. Now, you see, so there is a gradual variation of temperature distribution along the width direction as well as along the thickness direction, correct. Due to this variation of temperature, there is develop a temperature gradient through the thickness as well as you see through the width direction of the welding, correct. So, due to this thing in different location through the thickness direction, let us what happens, it has different, if we consider this plate has different layer, okay. Now, what happens, so this due to this different layer, if we consider that, so through the thickness different layer will have different types of expansion and contraction. During heating it will expand, during cooling it will contract. So, different types of expansion and contraction will be there. So, in this case what happens, so which will have more deformation, or you can say due to this heating, this more deformation will act as a act as a locking device of other layer which have lesser types of deformation, correct. This you should keep it in mind, because once there is a non-uniform types of expansion and contraction, so one layer will act as a locked mechanism with another layer, because that will either restrict or that will either support the expansion of other layer. Due to this thing, what happens, inside the structure there can develop some what it is called locked in types of stress. What happens here in welding, that things is occur, because what happens in through the thickness there can be different types of expansion, because in top layer there will be more expansion, just gradually this expansion we can say gradually decreasing through the thickness direction. And similarly, in width direction also there is a similar phenomena in the sense due to this variation of temperature there will be different types of thermal expansion due to temperature, because we know what is thermal expansion, because thermal expansion coefficient, let us the thermal expansion coefficient I am representing as alpha. So, we know alpha into delta T is called thermal strain. This delta T is what? Delta T is generally temperature difference between 2 points. What I am telling, understand? So, or you can say due to this temperature variation, or generally this if wherever the temperature difference between 2 points, not temperature variance at a particular location actually. Now, you see this is called thermal strain, this is called alpha T I am representing, this is alpha T is called thermal strain. Due to this thermal strain, what will be the thermal deformation? Thermal deformation, it will depends on the width of the or you can say length of the body. So, length let us say L. So, L alpha delta T will represent the how much elongation is taken place. So, L alpha delta T, this is very well known to you, I am not going in details. So, what happens due to this non-uniform temperature distribution along thickness as well as along width direction, there is developed a non-uniform expansion and contraction in welding. So, that is why this is called there is occur inhomogeneous types of plastic deformation, because in top layer there will be very high temperature. So, there will be more plastic type of deformation, whereas this bottom layer will have little bit lower temperature, there will be less what it is called plastic deformation. So, this top layer will act as a what happens locking device, or you can say this bottom layer will act as a locking device of top layer expansion. So, that is why what happens inside the body there is develop some locked in types of restoring types of force. Due to this thing due to this restoring types of force, or you can say resisting types of force, it creates some what it is called internal stress. So that internal stress is actually residual stress. So this macro stresses is developed due to this inhomogeneous plastic deformation. This thing can arise due to this temperature distribution, this thing can arise due to inhomogeneous types of external loading, or these things are also can be developed due to varied chemical diffusion. Varied chemical diffusion means a material can be made of different types of alloying elements. So due to these things, and if we just try to make some alloying by some electrode material, that with this electrode materials, this once is diffused inside the material, inside the parent material from that electrode material, or you can say from this filler material, then what happens, that also can develop some non-uniform types of or inhomogeneous types of plastic deformation. Due to these things, what happens, there can develop residual stresses. So one thing here you should keep it in mind. Residual stress means is a locked in stress. Once we just cut that locked layer, then what happens, this locked layer just spring back to its original position, spring back to its, that means the stress will release. So residual stress, one thing here you should keep it in mind, residual stress is a type of elastic stress. This you should keep it in mind, this because this stress is developed due to the elastic strain, because once we just remove this supporting layer or supporting restraint, then what happens, this will return back to its original shape. So this residual stress we can release, we can remove from the structure. So everything I will discuss in subsequent slide. Now second category is called type 2 residual stress, which is actually the intergranular stress, or it is called micro stress. So these stress actually are local small scale internal stresses which arise due to heterogeneities. These things you should catch. Which heterogeneities? Because what happens, this is arise due to the mechanical property of different alloying composition of a parent material. What I am telling you, so of the body, you can say, of the structure, we can say. So because a structure is made of different types of alloying composition. So what happens, this alloying composition will have different types of mechanical property as well as microstructural property. Mechanical property in the sense like mechanical property like Young modulus, yield properties, then thermal property like what happens, coefficient of thermal expansion. So it will have different types of this property. So due to this varying alloying composition and its varying mechanical and thermal property, so this alloying element will have different types of expansion and contraction. So due to this non-uniform expansion and contraction, what I have told you, so there can be developed some varying expansion and contraction of in that material, correct. Due to these things, what happens, there can develop internally some locked in types of stress. That stress is called type 2 residual stress. Okay. So this type 2 residual stress generally occurs when microstructure consists different types of phases during phase transformation also. And like you see in steel, once this austenite is a one type of phase, on this austenite here cool down, then what happens, it is converted to what it is called ferrite, bainite or martensitic types of structure. These are all called phases. So these phases will have different types of thermal expansion, as well as this will have different types of Young modulus, correct. Due to this thing and its phase transformation, what happens, and its varying mechanical and thermal property, there can develop some inhomogeneous expansion and contraction of different microstructures. Due to these things, in microstructural level, there can develop some locked in types of stress due to this inhomogeneous expansion and contraction of different phases. Due to these things, whatever the stresses develop, that is called micro stresses or type 2 stresses. And another categories of this stress is called type 3 stress, which is further atomic scale stress. Atomic scale stress, in the sense this stress arises generally due to coherency at interface and dislocation stress field. What is this coherency at interface? That little bit I am just telling. coherent interface is an interface across which the lattice planes are continuous, then that is called what is called coherent interface. Here one thing you should keep it in mind, that means this a coherent interface is formed when the two crystal, it is a crystallographic phenomena you can say, when two crystal or part of crystal has a good mass and the two lattice are continuous across the interface. Okay. These types of phenomena is called generally coherent interface. So, that whatever the interface is there of two crystal, that interface is called coherent interface. Here always keep this thing in mind, in most of the coherent interface the lattice plane are elastically strained. So, what I have told you, wherever there is a elastical strain, there can be, and if it is locked, then what happens, there will develop some what is called residual stress. That means most of the coherent interface the lattice plane are elastically strained to maintain continuity. This you should keep it in mind. This elastic strain play a crucial role in determining the properties of material containing such coherent interface. Okay. Because this elastic strain play a crucial role, this you should keep it in mind. So, this arise due to coherent interface. And another atomic scale, what is called atomic scale residual stress, which can arise due to the dislocation. Now, you know this dislocation, so then also I am just telling, a dislocation is a linear crystallographic defect, correct, or it is you can say, or a irregularity within a crystal structure which contain an abrupt change in the arrangement of atoms. What I am telling, understand. So, a dislocation can be characterized by the distance and direction of movement it causes to atoms in the lattice, which is called the generally Berger vector. That is very well known to you, I am not going on details. So, it is also a crystallographic defect. Due to this crystallographic defect also there can develop this type 3 or atomic scale residual stress. This you should keep it in mind. Okay. So, next class I will start from here. Thank you.